Alright guys, this is the second lesson about graphing more quadratics. Now we're going to see this in one more different form, but before we do that, alright, let's review about what we went over yesterday. So if you have a function that it's in vertex form, now vertex form is really easy to tell what it is because it looks like this. Alright, you have one parentheses square, and that's about all you have. Okay, so this is called the vertex form. So if you remember from the past, this is the stuff that we did at the beginning of the year. The vertex is going to be located at the opposite of this number, which is 1, and this number is going to be exactly the same. So we have that the vertex is located at 1, negative 4. Okay? Now, we're going to put that point at 1, negative 4. See, 1, 2, 3, 4. Now, before we actually start graphing it, remember that these are the points for the parent function of a quadratic. Remember, these are the points that we need. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And remember that I got the y coordinates by squaring the x, because this is y equals x squared. Okay, so before we actually start graphing these though, notice that I have a 3 here. That 3 is going to be a vertical stretch. Right, so what that's going to do to your graph is that it's going to grab this y coordinates that we came up with, and it's going to multiply each one of those by 3. And when you do that, instead of going up 4, you're going to go up 12, up 3, 0, 3, and 12. So these are my new y coordinates that I have to follow. Okay, so from this point, notice that my first point now is going to be, instead of 1, 1, is going to be 1, 3. So to the right 1, up 3. And my other point is going to be negative 1 and up 3. So to the left 1 and up 3. Remember that if you're confused about what I'm saying, that remember that I'm pretending like this point right here is this point 0, 0. I'm pretending like my vertex is 0, 0. And then from that point, I'm just going to follow this table. That way, I only have to remember one table instead of many. So we can probably plot the other 2 points, negative 2 and 12 and 2 and 12, but let's not. We don't really need that. So let's just call this. And if you notice, this parabola is a lot skinnier because you're doing a vertical stretch. It's like you're grabbing that parabola and stretching it out vertically. Okay, so that's that. Now the next one is kind of weird when you first look at it because it doesn't look like a quadratic function. However, I can rewrite this in this form. I have 3 x plus 0, x plus 2. Notice that I haven't really changed this, mathematically speaking. I haven't changed it. If I add a 0 to anything, it doesn't change it. But now I can tell that this is a quadratic function in the root form. Alright, where my roots are going to be x is equal to 0 and x is equal to negative 2. Remember that. I'm going to take the opposite of that number. And we'll talk about more about why that is. Okay, so to find my vertex though, this is going to take a little bit of work. So the first thing I have to do is plot the roots. Remember, the roots are the same thing as x-intercepts. Right? Roots and x-intercepts are exactly the same thing. So my x-intercepts, or my roots of the function, are located at 0 and at negative 2. Now remember that to find my vertex, the vertex is located right in between those 2 points. Alright, the axis of symmetry is right in between those 2 points. So I'm going to draw myself a little dotted line here to help me out. Now, again, this is called the axis of symmetry, and that's going to be located in this case as x is equal to negative 1. Right, so at x is equal to negative 1, that actually gives me the x coordinate of the vertex, because my vertex is going to be located somewhere on this line. Okay? So to figure out the y coordinate of the vertex, it's actually very easy. All I have to do is plug in this negative 1 right here into this x and that x. And whatever I get, well, that's going to be my y coordinate. So y is equal to 3 times negative 1, negative 1 plus 2. Now if you notice, this is going to give me negative 3 times positive 1, so y is equal to negative 3. Alright, so my y coordinate. Now remember, if you're watching this, I didn't come up with the vertex first. I had to do some work, and once I got negative 3, then I can come back and rewrite it here. So negative 3 is going to be located right here. Now let's make sure this makes sense. If we look at this, this is being stretched by a factor of 3. And I know my vertex is negative 1, negative 3, negative 1, down 3. And it's being stretched by a factor of 3. So my first point, instead of 1, 1, should be 1, 3, and it is. So it looks like I did this correctly. Alright, if you understand what points to use, you don't need to rewrite this every single time. Okay, so we're going to leave it like that. Alright, so that's actually what we did yesterday. There's nothing new here. So what is new, though, is that we have a new form. This is called a standard form, and you probably should be able to recognize this because you actually factor a lot of functions that look like this. Now, it's telling you right here that the vertex is located at negative b over 2a for the x-coordinate and at f of negative b over 2a. Easy, right? Okay, so this actually looks more complicated than it is. What you're actually supposed to do here is that the a, b, and c are actually the coefficients that you see right here. Alright, so a is actually, and you see there's no number here, but this is an understood negative 1. Alright, so a is negative 1, b is negative 2, and c is equal to 8. Now, I may not know anything about this, but however, I do know that this 8 right here, if this is in standard form, which this one is my y-intercept. So I know that I'm going to have a point right here. So, hey, there's one free point for you right there. Okay, so now the vertex is actually pretty easy. So I'm going to break this down. This right here, x is equal to negative b over 2a. That's going to give me the x-coordinate of the vertex. That's what that means. Alright, so let's plug all that in. Notice that I have b is equal to negative 2, so we have a negative of a negative 2 over 2 times negative 1, which is the a coordinate. I'm sorry, that's the a coefficient. That's the coefficient of x squared. So this is going to be positive 2 over negative 2. That's going to give me negative 1. Okay? So we have that our vertex, the x-coordinate, is negative 1. So just like we did on that last problem in the root form, what we're going to do to find the y-coordinate is we're going to plug in this negative 1 back into this x and that x and see what we get. Okay? So whenever you see this, which looks really complicated, but it's really not, it's just math is a different language, right? So notice that negative b over 2a, which is what I found here, so what that means is that this is f of negative 1. Translation. When you see something like this, what that really means is to plug in negative 1 for x. So what we're really doing here is that f of negative 1, that's the same thing as plugging in a negative 1 for x. And we're going to see what we get. And whatever we get, that's our y-coordinate. So, this is going to, let's see, f of negative 1 is equal to, let's see, that's positive 1, but that's going to make a negative. So we have negative 1 plus 2 plus 8. So that's going to give us, that is going to give us positive 9. Alright, so we have that our first point is at negative 1. Okay, so probably you don't know what that means. What I just found was basically it says if x is negative 1, then y is 9, which happens to be my vertex. Okay, so that's what it means. Alright, so don't get all confused about this. It's actually pretty simple. So, our vertex is going to be located at negative 1 and up 9. So, this is our vertex right here. Right, remember that we have an axis of symmetry that runs right through that point. And we know we did this right because this is being reflected and it's not being stretched. So my first point is to the right one, down one. Let's do a couple of points here. We have to the right 2 down 3. And then we have to the right 3 down 9. And remember that I know those points basically because I'm squaring the x. And then since I'm reflecting over the x-axis, I'm just making those y coordinates negative. All right. So instead of doing this example number 4, let's actually go ahead and look at the homework. All right, so let's take a look at our homework. All right, and let's take a look at, again, this is homework, WSQF3, which you probably got today. All right, let's take a look at this problem right here. Now, there's many ways to do this. There really is. There's at least 2 ways that I can think of. You can say, well, this looks like it's in vertex form, which it would be. Or you can say this in standard form. All right, so let's say that this is in standard form. So if this is in standard form, that means that A is 1. Now let me put the formula here. We have ax squared plus bx plus c. Now if you look, there's no x value here. You only have x squared and then a constant, which is c. Alright, so if you don't have that, then that means that b is equal to 0 and c is equal to 9. Now remember that because c is equal to 9, that means that that's your y-intercepts, or where it crosses the y-axis. Alright, so we have that right there. So from our formula that we had, we know that the x-coordinate of the vertex is equal to negative b over 2a. Now in this case, b is 0. So we're going to have negative 0, which is just going to be 0 anyway, over 2a. Now a is 1. Now 0 over any number is still gives you 0. Okay? So my vertex is going to be 0, comma, some number that I don't know yet, but I do know. And maybe you're already guessing what this is. So you have, and you can't really see it because I have a blue pen and this line is black, but my axis of symmetry runs right through the y-axis. Alright, so to figure out my y-coordinate, I'm going to plug in, and again, this is what you have for your formula. I'm going to rewrite it one more time. You don't have to rewrite the formula if you know how to use it, but remember, negative b over 2a was 0 for me, so I'm going to plug in f of 0, which that means plug in 0 for x into that equation. Alright, so that means the y is equal to 0 squared minus 9, which means y is equal to 9. So my vertex is 0, 9. So, okay, what does that mean? Well, it means that, I'm sorry, this is negative 9. It means that my vertex is located right here. It's not being stretched. So my points, if you remember, the points should just be the normal 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Alright, so we have at least those points. Remember that those points came from here. I'm pretending that my vertex is this point right here. I'm pretending that point is 0, 0. Then I'm going to the right up 1. Okay? And so on and so on. Now, that's all I'm going to do. Again, if you need to look at the key, I do not mind. You can use your calculator to check your answers, but please do try. If you need to watch this again, watch it. I'm going to upload it to YouTube.